Okay, well here's our second non-calculator question. So looking at this problem, we'll notice that first of all, you're given a point, x is 2, y is -8, and then you're given the slope, so you're given a differential equation. And part A says write an equation of a line. Well, you know that whenever you're asked to write an equation of a line, you need a slope and you need a point, because you're going to use the point-slope form, y minus y sub 1 equals m times the quantity x minus x sub 1 to write your equation of the line. So the slope formula is given to us by 3x squared over y. So now if we substitute the values 2 and -8 in, we get 3 times quantity 2 squared, all divided by -8, which is 12 over -8. And if we reduce that, divide by 4, we get -3/2. So that's our slope, and our point we know is given to us is -2.8. So I get y plus 8 is equal to -3/2 x minus 2. So there you go. Now just for doing that, you get 1 point for the correct slope, and then you get 1 point for the equation. Now they're asking us to use this equation to approximate the value when the input is 1.8. So I'm going to have 1 plus 8 equals -3/2. Instead of x now, I'm going to replace that with 1.8 minus 2. And then I'll solve that. So we know this 2/10. Sorry, you guys, I'm running out of room here a little bit. So can you follow my work? So y plus 8 is equal to -1.5 times -0.2. Okay, and we know that to be a positive 0.3. Now I subtract 8 from that, so I get, as my approximation, so I should do these squigglies, -7.7. And then you get your third point for getting that correct approximation. Okay, remember, tangent line is just the point-slope form. Now let's answer part B. They ask us to find an expression y equals f of x. Now we're given dy over dx is equal to 3x squared over y. So they're wanting us to get y by itself. So that means, of course, we need to separate, integrate, add a c. So I get dy, whoops, excuse me, let me get my little eraser here. So I'm going to multiply by the y. So I end up with y times dy equals 3x squared dx. And then I'm going to integrate, so I take the integral of both sides. So that results in, because remember we take the integral of a power, we add 1 to the exponent and divide by the new exponent. So add 1 to the exponent, 3x cubed, all over the new exponent. Separate, integrate, add a c. Okay, you know what, folks? Right now you've raked up lots of points. If you separated correctly, you got 1 point. If you took this integral correctly, it's 1 point. 1 point. 1 point. You couldn't ask for any easier 4 points on an FRQ. Now, if I clean this up a little bit, I end up with 1/2 y squared is equal to x cubed plus c. Now it's immediately that I substitute the point that's given to us. So we're given the point to -8. So it's going to be 1/2 times -8 squared equals to 2 cubed plus c. Well, -8 squared is 64, divided by 2 is 32, and this is 8 plus c. Subtract 8, and we get c is equal to 24. Okay, now we take that c and put it right back here into this equation. So now I have 1/2 y squared equal to x cubed plus 24. And our goal is to solve for y, so I multiply everything by 2 first. So I get y squared equals 2x cubed plus 48. Now I take the square root of both sides. Okay, and we know that the square root of y squared is the absolute value of y. Come on, I'm seeing too many of you missed that. Square root of 2x cubed plus 48. Now we know absolute value, we could either have plus or minus as a solution. Now not both, because it's only going to be one equation that makes this initial point true. Now if you look at the initial point given to you, The output is a negative 8. So therefore, my conclusion has to be it's negative square root of 2x cubed plus 48. And that is the solution. So again, the remainder of your points, you got 4 for getting up to here. You got a 5th point. Whoops, sorry. It's plus 1, not 5 points. Plus 1 for getting the C, and then plus 1 for getting the correct solution for Y. There you have it, folks.